Let's get this party started. So I am Sasha Rosenbaum, and this is a talk about SRE, DevOps, managed services, and our path to the future. I work for RedHat. You can find me on Twitter as DivineOps. It's especially useful if you like cats, because I like to tweet cat videos. The mic is static over here, and I like to walk around, so I will try to remember not to walk away from the mic. All right, before I start preaching about SRE, I'm going to briefly introduce myself. So I've been in this industry for a long time. It's about 16 years now. I started off as a developer. I actually have a degree in computer science. Then I went to ops and kind of what we call DevOps today. I've held a whole sorts of different jobs that didn't exist when I was a kid, like cloud consulting and stuff like that. And then briefly did a stint in DevRel and spent a lot of time actually in customer success and technical sales, which I actually love because it's a lot of fun. So this was a little bit about me. What about you? So who here thinks identifies as a developer? Okay, a couple people. Ops, DevOps, SRE, whatever we call it now. Okay. I guess everybody else is like, I'm not going to go through, security, product, everything. Who here is super, super new to DevOps concepts? A couple people. SRE concepts? Okay. All right. So that's good because there's going to be a lot of definitions and a lot of sort of introductory explanations of what it is all about. I'm going to be talking about this book a lot. This is a site reliability engineering book by Google. It's the one from 2017. There's a couple of them now. It's a really good book if you want to learn more. Before I do quote it a lot, but before we dive into the things I actually really like about the book, I'm going to start with the first thing, a sentence that I really, really dislike in the book. And that's a definition of SRE. SRE is what happens when you ask a software engineer to design an operations team. And I really don't like this definition because it's very classist. It implies that developers are better than operations people, that operations people never thought about automation. They literally didn't want to do it. And then Google showed up and made it all better. That is not what happened, right? So actually, it's not about giving ops to developers. There's a different definition. This is also in the book. It's SRE is roughly Google's implementation of DevOps. And this one, to me, sounds a lot better. So we've been talking about DevOps for over a decade now. I've been involved in DevOps Days for a long time. So this is a picture of DevOps Days Chicago organizers from 2014 and 15. And I'm the only person in this picture of 2 years of organizers who identified as a developer. I'm actually wearing the same t-shirt. Yay, that's cool. Anyway, all of the rest, most of the rest of the people identified as ops people, right? And they were like the hardcore, running data centers, running cables, installing servers, all of that stuff. And they really, really wanted to automate themselves out of a job. Like that's what they really wanted in their life. But it was really hard. And it was really hard for multiple reasons. And I'm just going to walk through some of them. So we're going to go back to the future, or back to the past in this case. And so in the 90s, I don't know if all of you were alive in the 90s or if all of you were adult enough to know what a server looks like. But basically, if you wanted to run in a, yep, Michael. Anyway, so basically a server, if you wanted to run a simple web application in the 90s, you actually needed to put a procurement order with your, with your procurement department. Sorry, I got stumbled there. Anyway, you had to actually buy a physical server, then you had to buy a physical server rack, then you had to, if you were unlucky enough to run out of data center space, you needed to buy more data center space. Then you need to wire up all the cables, you need to configure that. So all of this took months, right? So all you needed was a simple web app, but literally it took months of like trying to get this done. And of course, there was no automating these things, right? There was like actual humans doing all this stuff. And it was all one-off. Backups looked like this. It was on actual tapes. You ran this nightly. At one point, it was my job to like go around the data center and install, insert the tapes and run the backups. And then you ship them all to a offsite location. And then if you wanted to restore from backup, it took you potentially 2 weeks because you had to go fish the right tape and then like, go through like that pursuit, hope that it still works, hope that the data is still there. Anyway, it was a whole thing. And so this is a tweet from William Harold that says, I don't know, but I have a misguided nostalgia for getting paged and driving to our data center to physically restart a server in the middle of the night. This actually happened. Lots of people actually had to do this because this was the only way sometimes to rescue a server. And so there was actual humans, driving to data centers to restart servers. Also, in terms of software releases, so I'm going to pick on SQL Server here, but honestly, it was every single, big application or OS or anything out there. So this was roughly 2 to 3 years between different releases. And basically how it worked was release one version of software, then the developers went into a bunker and developed a whole bunch of different features. And they like actually never talked to customers because they thought they know better than the customer. So they worked and they had whole sorts of different development branches, and they like then tried to integrate it all together. Of course, it created merge hell, right? So merging the development branches took weeks, like literal weeks of people trying to actually be able to deploy this to production. This meme is like, this GIF is here for no reason other than I like it. So basically it was a whole thing to just even try to push software out. And then of course there was maintenance windows. Interestingly enough, this one still happens to this day. It's kind of funny. But basically this was extremely common. You just took your software offline for 2 days just to deploy a new version because that's how long it took, right? And so like, by the way, does anyone know how many nines was that? So if you had 2 maintenance windows like that, how many nines would that be? I'm going to make you do math. It's less than 2 nines because 2 nines only gives you 365 days a year. So essentially, this is just a number out there. Unavailable systems were estimated to have cost American businesses $4.54 billion in '96, right? So it's just a number to put it in perspective. That was, systems were largely unavailable in the '90s and 2000s. That was like a thing. And then we used to think that speed and reliability were on the different side of the aisle. So dev was incentivized to build for speed. So like new features, developers wanted to release new features and build new innovation, and they were paid to do that, right? And then on the other side of it, ops were paid to like keep the lights on and not let anything break. And mostly things broke when people pushed new code. So that was a whole thing with ops and dev basically fighting each other. So luckily for all of us, people had good ideas about how to reconcile all of these incentives. And so in 2009, Patrick Dubois and a bunch of other awesome folks started DevOps Days. The first one was in Ghent. It was a small conference where people got together and talked about how to solve these problems together. And then it grew to like this global enterprise with lots of events running across the globe. In 2019, before the pandemic, it ran in 73 different cities. Like I said, I've run one in Chicago. There's one in almost every big city that you can think of. Picture of Bridget is on here because she helped grow it from like these like 4 events in 2010 to like a major global community. And we know now that actually speed and reliability are not on the opposite side of the aisle. So State of DevOps report has been out for a few years now. And we know that companies that push to production more frequently actually also break things less and recover from failure faster. So when we think about pushing software, when we think about things that are hard, we usually think about slowing down, right? If you don't know how you're doing, you should slow down and take your time. But in software development, what works better is actually an analogy of a bicycle, right? If you go too slow on a bicycle, you're going to fall off. right? So you have to go at a certain speed to be able to maintain a balance. Or the other analogy I really like is software delivery is like a muscle. The more you use it, the stronger it gets, right? So if I'm pushing to production once in 6 months, if I'm working a muscle once in 6 months, I'm really weak and then I hurt after that, right? But if I do it every week, then I get better and I get better and I fix problems and I get like actually exercise and learn how to do it better. But the problem with all of this, apart from like all of these systems being disparate and unreliable and all of this stuff, effective automation requires consistent APIs, right? So one of the words that is going to come back here in the talk a lot is APIs. They're really important. And consistency of APIs is really important to software development. And so the first thing that we need is operating system level APIs. So if we take Linux, we're actually lucky here because it's a file-based operating system. So you can actually make changes to configuration into OS itself by just writing the files. So technically it has an API, right? And we could always write a script to automate things on Linux. On Windows, it wasn't quite like that because it's an executable based system. And it was a huge part of the server market, as you can see in like 2000, just again, a stat that I could find for a particular year. But basically, Windows did not used to have an API and things used to be configured in the registry, and the registry, like the registry developers did not necessarily expose these in a programmable fashion. So you couldn't automate changing things on Windows. Which brings me to one of my favorite transformation stories, a story about Jeffrey Snover championing PowerShell, which is a Windows configuration management framework, CLI, and scripting language. It came out GA with Windows 2006. And before that, Jeffrey spent 5 terrible years trying to convince business executives at Microsoft that PowerShell was a good idea and that you should actually have a CLI for Windows. With a lot of people yelling back at him, which part of effing Windows do you not understand? The OS actually is called Windows, right? Admins don't want CLI. Turns out admins do want CLI. So luckily for all of us, automation wins in this battle. So every wave of automation enables the next wave of automation. So the next thing we came up with was infrastructure level APIs, right? So if we look at Google Borg, central to its success and its conception was the notion of turning cluster management into an entity for which API calls could be issued, right? So Google actually automated not just the OS, but also deployments of actual servers, of actual clusters, so we zoom out and we start deploying infrastructure at a very high level, at a very efficient level, right? And Google was not obviously the only company. Amazon did it around the same time. So did Azure, Microsoft in general. So all these companies, also some other companies out there like Netflix, all of these companies were looking to deliver adaptable services at scale. And the only way to do this was automation. Also, not everybody is Google and not everybody can just like design a server spec and order a whole bunch of the same server racks and install them in massive data centers and automate it that way. So also at the same time, there was a number of startups who started doing infrastructure as code. So enabled infrastructure level automation in your own data center. So like if you had your custom data center and you ran God knows what, companies like Puppet and Chef started writing basically code that allowed you to expose an API on top of these things. So as we said, every wave of automation enables the next wave of automation, which brings us to how we got ready enough and mature enough to implement SRE, right? So at the first time like the SRE book came out, I kind of actually thought it was mostly hype, right? Like we just renamed something and it's cool because it came from Google and stuff. But actually it's a little bit more than that. The book actually helps codify some of the things. So we've been talking about these things in DevOps circles for a decade, right? But you have to sometimes codify and give people common language and common tools and common metrics to be able to all be on the same page and work together. So second important word to this talk is incentives. Humans usually do what you incentivize them to do. So if we talked beforehand about developers and operations and how they were incentivized to do opposite things, That's why the whole thing generally broke and people threw tickets over the wall and blamed each other for things not working, right? People usually do whatever you metric them to do, whatever you incentivize them to do, which is why metrics are very important. It's also like metrics can also screw you over, but that's a whole different conversation up for this talk. So Google defines something, and again, this is not my favorite word, but it's one way to put it in. It's better than not having a language for it. Toil. It's the kind of work that tends to be manual, repetitive, automatable, technical, devoid of enduring value, and scales linearly as service grows. So if you think about that, William driving to the data center to reboot the server, and if you think that every server requires a reboot, let's say every 100 days, and let's say you have 100 servers and every single one of them requires a reboot every 100 days, and let's say the only way to do this is manually, then you need 100 Williams, right? And if you, the more servers you have, the more Williams you need to actually physically drive to data centers and reboot servers, which is not a particularly useful way to do this, right? So what we want to accomplish here is enable automation for that kind of stuff, right? So again, what Google and Microsoft and Amazon do, they just take servers offline after a certain level of unavailability, right? And again, they can do this because they're at a whole different scale. But again, you're trying to take the human out of the work here and enable automation. But so the other important thing about toil is you shouldn't strive for zero toil. So some companies make this mistake of thinking like, oh, we're just going to automate everything. The only way you're going to automate everything is by learning what should be automated, right? So before you learn what problems you need to solve, you can't solve these problems. So Google, and this still, I checked, it's still the number, they enforce under 50% toil, and they enforce it, right? So once people are doing more manual work than 50% of their time, they stop and they fix, essentially address technical debt until they can get back to roughly 50%. But also they're not, again, not aiming for zero. The other very important concept to the whole SRE thing is SLIs, SLOs, and SLAs. So we're going to do some definitions. So SLA has been around for, decades. It's financially backed availability. So service level agreements, I promise you, say 4 nines, and then if my service goes down for a certain amount of time, I owe you money, right? Again, that has been around for a long time. And I need some water. So the second definition, again, this has been around for a long time. Service level indicator, right? It's your actual availability. Hopefully you measure it. Like hopefully you actually know if your service is up or down, right? Because that's important. The new concept to the whole thing is SLO. So SLO is service level objective, and it's business approved availability. So what's new about this is that we're not talking about 100%. So it used to be that businesses would actually ask for 100% availability, right? Like we would aim for 100% availability. So anytime your service is down is a problem and everybody gets paged and everybody gets yelled at, right? Now, with the definition of SLO, we actually agree that that's not what we're looking for, because 100% availability is unattainable, unnecessary, and also extremely expensive. So let's not even talk about 100%, but like 5 nines. The 5 nines is everybody's holy grail. How much downtime is that? That's about 5 minutes a year. Okay. And an important question is, will your end users actually notice? And the answer is resounding no, because your internet service provider background error rate is up to 1%, which eats into your 9, like your 5th 9, right? So your end users will not notice that you're that available, because essentially their internet will not be good enough for them to experience your 5 nines availability. So SLOs are about aligning incentives between business and engineering, getting everybody to be on the same page, that we're not aiming for 100%, we're aiming for slightly less than that. And the concept that comes hand in hand with SLOs is error budgets. It's acceptable level of unreliability. So error budget is at 1 minus the SLO. So let's say you had an SLO of 4 nines, right? That gives you 0.01% of unavailability, which is 13 minutes a quarter, which is still not a lot of downtime. You're still available most of the time, right? 13 minutes a quarter is not so much, but it is significantly more than 5 minutes a year. So you have some wiggle room in there in terms of making mistakes. So error budgets are about aligning incentives between developers and operations. So we're trying to align business to developers. Now we're trying to align developers and operations. Because if developers are measured on the same SLO, then when the error budget is drained, developers slow down the push velocity to meet the SLO and avoid stalling major releases. There's a lot of words on the slide. So think about the situation where we've been working for a quarter, we experienced some minor downtimes, right? So we had a downtime of, let's say, 10 minutes out of 13 that we have, okay? And now we have this major release coming up when we're working on it, okay? And I'm, as a developer, I'm trying to push it through, okay? But then I know that I only have 3 minutes of downtime left. So if I'm basically incentivized on the same SLO that operations people are, I'm going to slow down and test that release as much as possible so that I can make sure that it's not going to exceed the error budget and then everybody gets dinged on performance. Because I want to put that big release on my performance review at the end of the year and get promoted, right? So aligning incentives. So aligning incentives essentially allows you to have speed and reliability instead of speed or reliability, and kind of make everybody be on the same page. Now, it's not perfect, but it gives you the ability to reason about these things. That's much better than people yelling at each other that, you know, they don't agree. Other important things to SREs, monitoring. So monitoring is how you manage your known unknowns, which involves checking values for predefined thresholds, creating actionable alerts, and runbooks and so forth. So essentially, if you don't have monitoring, you don't know if your service is working, which is not a good place to be. And it's actually surprising how many people don't actually have good monitoring, like not have decent monitoring set up. So they actually, like, we're talking about 5 nines and whatever, and like actually they don't actually know if their service is down. The only way for them to know is that customers call them. The other thing that is really important about monitoring is signal to noise ratio. So you have to get this right, because if you don't, essentially, if you have a bad signal to noise ratio, one option of that is people get paged about nothing. So you actually don't know when your service is down and you don't know that you need to fix it. The second option is you get paged about everything, right? So people start ignoring alerts, and essentially this is all noise, right? And then again, you don't fix anything because you don't know how to differentiate that something is a real error or not. The good rule of thumb is to page people only about things that are humanly actionable, and only page people who can actually take the action, right? So you have to have the rights to fix the production issue if you're getting paged, and it has to be actionable. If you get an alert that's like, oh, in 2 days, you should, like, I don't know, clean your backup tapes because you're running out of space. Like, okay, well, I'm going to ignore this next time. Okay. The next, it's kind of a new concept. You know, that's been getting popular the last few years, observability. So observability is how you handle your unknown unknowns by instrumenting your code and capturing the right level of detail that lets you answer any question. So where monitoring is about asking questions you already know, right? What's my CPU level or something? Observability is about being able to have enough data to ask the questions you didn't think about asking, right? Kind of ability to research what your application actually does. Caution. So this cautionary tale, we talked a lot about automation, and it sounds like automation is going to solve all of our problems. It's not, because automation has its own problems, right? So while automation is really good, so there's a couple of tweets that are like, I mean, yes, automation eliminates human errors in the sense that those errors will now be performed by machines. Nobody laughed. Oh my God. This is fine. It's fine. The second one is like actually more near and dear to my heart. Is like automation, how to make mistakes consistently, repeatedly, and really fast. So I'm going to pick on Facebook a little bit. They recently had an outage. They were taken out by updates to like their DNS and BGP, and essentially, you know, became unroutable from anywhere. this is not just Facebook, like literally every big company out there has been taken down by the wrong script running with their own parameter or something like that. Automation allows you to actually take down a whole lot of servers with one click of a button or one wrong push of a script, right? So there's a danger there. Second one is, you can basically develop something. The moment you develop something, you have to maintain it. Automation has to be maintained, right? And so the moment you develop automation to run a particular system, it starts getting automation drift, right? So the system is getting updated. And unless you update your automation, you're going to experience technical debt, which means the automation is going to break more than it fixes. The next one is like, automating one-offs is highly inefficient. It's like the tweet is, why spend 2 hours doing a manual task when you could spend 6 hours automating it? But the problem is not the 6 hours, but like if you really haven't, if it's not justified, if you only needed to do this task once or like once a quarter, then like really you shouldn't automate it. But if you do it every day, then you really should. So again, we are not striving for 0% toil because we want to make sure that we're automating the right things. So these are the drawbacks of automation. My favorite one is that all systems are socio-technical. So one of the things that happens when we talk a lot about automation is we start thinking that humans are the problem. And so the moment we take humans out of the system, everything's going to be perfect. Well, that's not true because entropy always wins. So all systems left to their own devices strive towards chaos. So no matter how good the system is, if you left it to its own devices, it would just eventually deteriorate. And so you always need humans. You need humans to maintain, you need humans to develop. Essentially, again, we're never going to be able to take humans out of socio-technical systems. Okay, so let's shift gears a little bit. We talked a little bit about the past, a little bit about the present. Let's talk about the future. So as usual, the future is already here. It's just not evenly distributed. So we talked about 5 nines and companies that like automate everything about their infrastructure and whatever. And like really there are companies that push on every commit and like, scale to the entire globe and run very productively. This is like, was a tweet from someone, I'm not going to quote the name, but DevOps is a solved problem. And then you take the survey. This survey, this was the last year it's ran. Otherwise, I would have like more recent numbers. But anyway, in 2018, Stack Overflow asked the question of like, what do you use for version control? And like 8% was like zip file backups and copying and pasting files to network shares. And I don't use version control. Like you've got a lot of people who don't know what version control is out there in 2018, right? It's kind of sad, but like that's the reality of it, right? And then you've got how often do developers check in code? And here also we have this kind of less than 1 per month and never. So lots of companies out there are actually nowhere near all these fancy bells and whistles and kind of struggling with like the basics. So you got to know where you are. If knowledge was all it took, we'd all have 6-pack labs. Unfortunately, that's not true. So what I think, and I'm a little bit biased because I work for RedHat and we actually develop managed services, but I think the future is in managed services. I think the future is in platform as a service. So most companies don't need to develop their own custom infrastructure or their own custom applications. Like they need the custom applications, but not the platform level customization. So we've wanted PaaS for the last, my slide says 10 years, but I think it's more like 20. Like we've wanted platform as a service forever. And we've made a lot of attempts to actually implement platform as a service on commercial platforms. Problem is that PaaS works if your environment is homogeneous. Problem is that your environment is never homogeneous, right? Every enterprise out there has lots of legacy code, lots of acquisitions, lots of different infrastructure that came from different tech stacks and lots of different code out there, right? So as we said, effective automation requires consistent APIs, which means that it's really hard to do PaaS because you want both standardization and customization at the same time, and that's where it breaks. And I need some more water. 45 minutes is a really long time. So as we said, every wave of automation enables the next wave of automation. And again, I'm slightly biased because of where I work, but I think that Kubernetes is that path to the future that enables us to standardize. Now we're still not there, right? Kubernetes is still pretty low on the percentage of people that deploy it, but 85% of global IT leaders agree that Kubernetes is key to their cloud native application strategies. And I don't know about the not cloud native application strategies, but at least for cloud native application strategies, we standardized on something. And again, standardizing is good because it gives us a consistent API. So in theory, we can reach a point where everybody is deploying in the same way and they can leverage the same tools and they can standardize, which means that any enterprise out there, not just Google and Microsoft, can start automating things. Also, open source is really cool because open source allows us to share knowledge, which also means that we can standardize on the processes and tools that we implement. Unfortunately, the problem with open source is that this is a mandatory CNCF landscape slide. There's over 1,000 services on there. And I have to periodically update the screenshot because like 20 new services join every month. And consequently, this is what operating Kubernetes in production usually looks like. Fortunately, you now have choices, right? So if you don't want to be in data center management business, you can go to the cloud. And if you don't want to be in Kubernetes management business, again, I'm biased, you can go with OpenShift. But again, even just standardizing on Kubernetes itself allows you to have that consistent API. So like once we get to the point where major parts of our critical infrastructure are actually running on Kubernetes, we will get to the point where we can actually have repeatable automation and paths for everybody. Red Hat actually deploys managed services, so OpenShift on all the major clouds as well as on-prem. So we kind of standardize across all these different platforms. And so the goal here is that your infrastructure services are operated right by the cloud, hopefully. And your platform services are operated by your platform provider. And then all you have to do is run your applications because no one's going to run your custom applications for you. But you build it, you run it, you're responsible for the SRE of these particular pieces, but you want to outsource the other pieces of it to your platform providers. Now, this is an important question. Do you know how your company makes money? I stole this question from Ed Stratton. He really likes to ask it. I think he asked it on a ATO stage a couple of years ago, but anyway. So it's important to know how your company makes money, because if building paths is not your company's business goals, then I would outsource SRE to your platform provider, right? Because that's a smart choice. Because really what you want to do is get your skills above the API. So this illustration actually comes from Hans Moravec, and it's an illustration for AI. So it's an AI landscape. We're talking about automation, and it's essentially the same thing. So the way to picture this is there is a landscape with like plains and valleys and mountains, and AI gradually raises the level of its capabilities to where it starts to take over particular pieces on the landscape, right? So particular skills on that landscape are now done by AI. It's the same with automation, right? So like if you are a driver and we're developing self-driving cars, your skills are gradually getting below that API, right? So this is where you don't want to be. You don't want to be a driver if all the cars are going to be self-driving because your skills are now not useful. So again, if your company is not in a PaaS business, then you probably don't want to learn how to operate Kubernetes, because ideally in the future, we're getting to the point where that stuff is all below the API. Now, if you are in the business of building paths and that's your actual business goal, or you want to work for a company that is doing that, then you should get really good at it. So again, I've been in the DevOps community for a long time, and we used to tell people not to call themselves DevOps engineers, but it turns out that we created new jobs, right? This community actually created new jobs, created a lot of new jobs. Actually, this is like everything ops related landscape from like 2021, and this is ridiculous, but yeah. And the reason we stopped telling people not to call themselves DevOps engineers is because, so Paul Reed there on the slide, on the picture, started running something called TalkPay, where people could anonymously share their salaries. And it turns out that DevOps engineers get paid more than ops, like change in title actually, or in skills, right, gets you paid more. And we want people to get paid more. That's awesome. So if we look at actual stats, DevOps and SRE engineers command higher salaries. They also work on more interesting problems, which is, I think, is a cooler thing to accomplish, right? If I talk to my friends, you know, again, from DevOps in Chicago, they have successfully automated themselves out of a job. They automated themselves into far more interesting tasks, and that's cool. So we are at RedHat also running on an SRE journey. So like I said, we're running all these services across different clouds, which is an interesting thing because we're solving the exact same problem that every company out there is trying to solve, right? How to run a platform on top of someone else's cloud. And we're trying to get really good at it. So actually, when we started a few years ago, we were like at 2 nines. And we gradually got to 4 nines, and we're trying to get better. We're trying to, you know, get more availability, get more metrics that are allowing us to automate things and, you know, run SRE effectively. And I'm shamelessly going to promote the fact that we're hiring, so you can join us and you can stop by the booth and, you know, talk to us. And then last but not least, I'm actually probably going to finish under time. So if anybody has questions, we're going to have time for that. Ideas are open source. So I took a bunch of ideas in this talk from other smart people, and hopefully other smart people take ideas from me. We should all share knowledge. This is, you know, how we get smarter. So Red has started this initiative called Operate First, a concept of incorporating operational experience into software development. Kind of concept of democratizing SRE, right? So we actually want to, if you think about pushing like upstream first, right? Push all your changes back to upstream. That's what we're trying to do with SRE knowledge. We're trying to push it back to upstream. It's very initial stages. There's a website out there that you can go contribute to, and you can help us build it out. The aim is to both create kind of learning materials for people who want to get into SRE and push SRE knowledge back to upstream so other companies and other people can leverage it more easily. So to summarize, the most important things to software development are APIs and incentives. So if people in your company are arguing about how to get to a better place, usually you should look at one of them or both. And these are resources. I don't know, you can take a screenshot or you know, just kind of Google it online. So the Google SRE books are good and they're free on the Google website. The Operate First is a website I just mentioned. There's lots of books on DevOps. So I still near and dear to my heart is the Phoenix Project and the Continuous Delivery book, which is kind of where it all started. And then there's Accelerate, DevOps for Dummies, and the DevOps Handbook, actually new versions coming out this year. And then again, shamelessly promoting that RedHat is hiring. So I didn't put a particular link on here. You can search for, because job titles, job locations change. But we're hiring both for the SRE team and for the Black Belt team, which is my team, which is technical sales if you want to talk to customers. Like I said, it's fun. And I did contribute a chapter to this book, so you'll go buy it. I don't actually get paid for it, so like it's all community work. This is the second time I write a book, and the second time I'm not going to get paid any money for it, so it's terrible life decisions. Anyway, so thank you all for being here. I am Divine Ops on Twitter. I would love to continue this conversation because I think there's a lot to talk about. And also, yes, you can follow me on Twitter to get cat videos, and you can stop by the booth and talk to other people about RedHat and about the stuff that we're doing in the Operate First conversation.